writing a chemical equation. In a chemical reaction, the reactants, one or more, react together and form a new compound known as the product. For example, aluminium oxide reacts with dilute sulfuric acid to form aluminium sulfate and water. This reaction can be written as Al2O3 plus H2SO4 gives AlSO4 3 plus H2O. The following steps are followed to write a chemical equations. Symbols and formulas of reactants are written first on the left hand side. If there is more than one reactant, then a plus sign is placed between the different reactants. So if there is more than one reactant, over here we have more than one reactant, so a plus sign is placed between the two reactants. Aluminium oxide and dilute sulfuric acid, for instance, are written as Al2O3 plus H2SO4. So these are written as Al2O3 plus H2SO4. An arrow is marked after the reactants to indicate that they react to form a product. So an arrow is marked after the reactants to indicate that they react to form a product. Symbols and formulas of compound formed, that is products, are written after the arrow on the right hand side, which indicate that these are formed. Like we have an arrow, so this arrow indicates that the product over here, which I will write, is formed. Here also a plus sign is placed between the different compounds formed. So it will be written as AlSO4 3 plus H2O. Sorry. So this indicates that this product is formed by the reaction of these two reactants. So this arrow acts as an indicator. Like in maths, we have an equal to sign to indicate that this is equal to this. So over here, the arrow acts similarly to indicate that this is equal to this. And like in maths, we have equal to sign. So the left hand side of the equal to sign is referred as LHS, that is left hand side, and the RHS of the equal to sign is referred to as RHS, so that is right hand side. Similarly, left side of the arrow, that is reactant side, is referred as left hand side, LHS, and the right hand side of the arrow, that is the product side, is referred to as RHS, right hand side. Balancing the equations. The chemical equations are based on the law of conservation of mass that we studied last year in standard 9, chapter 3. According to this law, mass can neither be created nor be destroyed in a chemical reaction. This will be possible only if total number of each type of atom is the same on the reactant side as well as on the product side. Equation in which the number of atoms of different elements in the reactants are the same as the number of atoms on the product side are known as the balanced equation. I repeat, equation in which the number of atoms of different elements in the reactants side are the same as on the product side are called balanced equations. So let me give you an example. Al2O3 plus H2SO4 gives Al2SO43 plus H2O. This is a similar example we used last time. So the above equation is an unbalanced one. There is only one atom of sulfur in the reactant side. There is only one atom of sulfur on the reactant side, while there are 3 atoms of sulfur in the product side. So reaction should be Al2O3 plus 3H2SO4. So sulfur becomes 3 times, so this is 3S gives Al2SO43 plus H2O. So the sulfur becomes balanced over here. Now there are 6 hydrogen atoms on the reactant side. There are 6 hydrogen atoms. So this is 3H2, that becomes 6H, 6 hydrogen atoms on the reactant side, while there are only 2 hydrogen atoms on the product side. Sorry. So there are 2 hydrogen atoms on the product side. So we need to balance this again. So if we take Al2O3 plus 3H2SO4, that becomes Al2SO43 plus 3. This is important. This topic is very important because this is the basic of chemistry, which we are going to learn in the next years. Chemical equations are the most important part. So these are the basis. This is base of chemistry. So this becomes 3H2O. So hydrogen become balanced, 3H2, and over here also 3H2, that is 6H, 6 hydrogen atoms. Now in the equation 3, the oxygen atoms are 15, both in the reactant side, both in reactants and product side. So oxygen atoms are 15. So this is 3 oxygen. So let me write here. So this is 3 plus 3 4s are 12. So 12 plus 3 is equal to 15. And over here, that is 4 3s are 12. Sorry, this is 15. So this is 12. And this is 3O, 3H2. This 3 is applicable for H2 as well and as for O. So 12 plus 3, that is 15. So the final balanced equation is Al2O3 plus 3H2SO4, that gives Al2SO43 plus 3H2O. Dear friends, this is a method. So but this method is also known as Tukka method. I repeat, this is known as Tukka method. Tukka refers to guess. So in this method we need a very wild guess to get the reaction balanced. So I'll teach you another method, algebraic method, algebraic method. So this method uses algebra to solve chemical equations. It is very easy. It's not too tough, so don't worry.